your program or scan it up here on the screen and send in your questions for our panelists. Now, if you read MIT Technology Review, and I hope that you all do, you know that we cover a wide variety of technologies. We write about biotech and climate technologies, but artificial intelligence is one of our core beats, and our team of reporters focused on AI has been especially busy over the last 15 months since ChatGPT was released. So I thought what I would do today is just tell you a little bit about how we got to this moment, describe some of the major players out there in generative AI, talk about some of the models you might want to know about, discuss some of the challenges that these models and their makers are up against, and also describe where our team believes this is all headed. Keep in mind, I'm not an AI expert myself, I'm a journalist, so this is meant to be more of an overview or a refresher on some of the main topics to know about related to generative AI. So first, I thought a good place to start might be just taking a look back at important moments throughout AI as a way of reminding ourselves that AI is not new. And even generative AI, which feels like it's sprung up really suddenly, is not new. The techniques underlying it have been in the works for many years. So here's a little recap of some big moments in AI, many of which we've covered at MIT Technology Review. This is not a comprehensive list, but hopefully gives you a sense of what's happened leading up to today. In the 1950s, Alan Turing described this idea of a computer that could learn from experience. He predicted that one day computers would be able to play chess, and he described the Turing test, which was his way of gauging how intelligent a machine was. Then if we fast forward to the 1980s, Geoffrey Hinton and two colleagues developed backpropagation. An algorithm allows machines to learn and which underpins modern neural networks. It wasn't until the 2010s, though, that neural networks really started to be good enough to do things like identify objects in an image or predict the next letter in a sentence. And if you're not familiar, neural networks are a type of software architecture that has many different nodes and connections between these nodes, and the weights of those connections can be adjusted, increased, or decreased as the machine learns. One type of neural network that's been especially important to generative AI is something called generative adversarial networks, or GANs. And you can see this article here we did on Ian Goodfellow, who's one of the pioneers of GANs. This is a technique in which you take two neural networks trained on the same data and set one of them to generate something new based on that data, and set the other one up to interrogate and judge the output of the first, and give it feedback essentially to make it better over time. And this is partly what's allowed new generative systems that we have today to produce the stunning images and content that we see. Another enabling technology was transformer architecture, which Google introduced in 2018 with BERT, the same year that OpenAI released the original GPT model. And this is also part of what makes these systems so good at predicting what comes next in a sentence. It's using a lot of math to figure out the context between words and how they relate to each other. And then in 2022, this is when generative AI really started to take off and when many people in the public began interacting with it directly for the first time. So if you remember, in April of that year, OpenAI released DALL-E 2, its image generating tool. Put it out online and people started playing with it, generating lots of weird, wacky images in all kinds of different styles. This bowl of soup that looks like a monster knitted out of wool is one of the first images from DALL-E 2 that we published. And Midjourney, which is a text-to-image model, came out around that same time and really started to gain traction with the artist community in particular. Stability AI put out Stable Diffusion, which was an open source text-to-image model in August of that year. And then in November, OpenAI released ChatGPT, which really took the world by storm. That became the fastest growing consumer app of all time, reaching 100 million monthly users in just 2 months. So absolutely extraordinary growth. It actually even took OpenAI by surprise. They did not expect ChatGPT to be that popular that fast. So all of these developments over the years in using neural networks to do natural language processing and image classification, in deep learning and in self-supervised training techniques have led us to where we are today, which is just this explosion of interest and investment in generative AI. And these are just some of the primary foundation models that are out there now, and the major players involved give you a sense of where they are. OpenAI has now progressed to GPT-4, and it has ChatGPT, which is based on GPT 3.5, and also is on the third generation of DALL-E, the image generation tool. Recently, it released Sora, a text-to-video tool, so that's brand new. Google has Gemini, which it says beats GPT-4 on many performance metrics. Anthropic has Claude 3, which just came out a month ago, their latest version. Meta has Llama 2, an open source large language model developed for research and commercial use. And Hugging Face has Bloom, which is also open source and works in 46 human languages and 13 programming languages. Now, over the past year, we've really started to see more of these tools be integrated into software and services that millions of people are using every day. So even if you haven't logged on to ChatGPT yourself, there's a good chance you're still using generative AI somewhere in your life or work. Here are just a few examples of that. Adobe has Firefly integrated into its photo and design suite, and we recently had a story on how that model was built using all imagery that was licensed from artists or already owned by Adobe to avoid some of the copyright infringement issues that other model makers are running up against. Microsoft and OpenAI have been working really closely together. Microsoft has invested more than $10 billion with a B, dollars into OpenAI at this point, and they're now using OpenAI's models in Bing, for search, in Microsoft 365, that suite of products formerly known as Office, that includes tools like Teams, Word, and Outlook. Microsoft has more than 1 billion users globally across all of its products, so there's a lot of people out there already using generative AI in their work and daily lives. Microsoft also launched Copilot, what it calls your everyday AI companion, and has been investing really heavily into developing tools for programmers to code using AI. And then over at Google, they have done the same with Gemini. They're integrating it into the Android development process as a kind of AI coding assistant for anybody who's building apps for Android devices. And they're also working it into Google Drive products. A lot of people, though, think that the technology's potential for generative AI is even bigger than that. So it's not just going to make the tools that we already use a little bit better, but it's going to really transform the whole paradigm of how we work and communicate and interact online. I recently had the opportunity to interview the chief scientist at Microsoft on stage at a different event. We were talking about Bing and the future of online search. And to paraphrase her, she said, if we are still thinking about search as just a way to surface and organize a list of links, we're stuck in an old mindset. She really believes that generative AI will fundamentally change the way we seek out and process information online, make it more like a conversation. So a chatbot's going to be more like your helper, figuring out what you want and how to go and get that information for you. And my colleague Will Douglas Heaven just published an interview with OpenAI's first ever artist in residence named Alex Reben. And this is one of Alex's artworks that he made with generative AI. Back when OpenAI released DALL-E 2, its image generation tool, Will wrote a great story about the nature of creativity and how we might need to redefine what it means to be creative now that humans are collaborating so closely with these tools and that we're using AI to generate ideas and find inspiration as well as create images. So these tools are really bringing up a lot of interesting questions about how we work and the nature of creativity and how we interact online. It's really just fascinating to think about. But as I'm sure you've also all heard, there's many new challenges coming up with these tools because many of them are trained on data scraped from the internet. They've ingested and reflect our own societal biases. So here on the left, you can see images created by researchers at Hugging Face using Stable Diffusion and DALL-E 2, showing what these models think of when they're asked to generate images of artists, a very particular kind of artist, older white male. And on the right, you see a test that our own senior AI reporter, Melissa Hekela, ran on a virtual AI avatar app called Lenza. Now, Melissa's of Asian heritage, and you can see that it generated highly sexualized images of her, whereas when some of our white male colleagues tested it out, they got images of themselves as astronauts or warriors or rock stars. There's lots of other issues, of course, the tendency of these models to hallucinate or make things up. They can be used to generate harmful content, including malware or deepfakes. And there are companies that have started to integrate and hardwire different controls and limits on these tools, but there's also the problem of jailbreaking, so people trying to figure out ways to write prompts that will make the model do something it wasn't programmed to do. So we're in the middle of all this, and the fixes are not yet perfect. Plenty of other challenges as well, especially legal and environmental ones. So there's lots of IP lawsuits ongoing right now by writers, actors, artists, even newsrooms, claiming copyright infringement because the makers of these tools have ingested their data or articles or works of art to train these systems. We wrote about an artist named Greg Rukowski, whose name was being used tens of thousands of times in prompts for stable diffusion by people wanting to generate images that looked like his artwork without paying him. Another big challenge is compute demands for these very powerful systems and their very high energy consumption. OpenAI says the compute power needed for foundation models has doubled every 3.4 months since 2012, so that's extraordinary growth adding up to real environmental costs. And another challenge is that AI policy is still taking shape. China has been really ahead on setting rules for generative AI. The EU has now passed its AI Act. Last fall, the Biden administration issued its executive order on AI, so there is progress here, but there's still not a lot of clarity for organizations and companies that want to move forward and start working with these tools and integrating them into products and services. There's also what I'll call some open questions remaining about artificial intelligence, things that could be challenges or opportunities, depending on decisions that we all make. One is economic impact. It's still too early to know whether these tools will boost productivity and increase the standard of living for most people, or whether they will further concentrate wealth and exacerbate wealth inequality globally. We don't really know how they're going to be used yet. There's some early applications, customer support chatbots using these to generate code, write copy, make images, but nothing that's really taken off or been super transformative. So I think we're still kind of waiting to see what or if that will happen. And there's big sectors of the economy like healthcare and education, where the impact isn't really clear. These tools are kind of just starting to make their way into these sectors, and we don't quite know what the impact will be there yet. And of course, what will all this mean for workers? There's been consistent research showing that using a tool like ChatGPT can help lower skilled workers produce work more on the level of higher skilled workers. So if you're not a very good writer, it can make you a much better writer. But what will that actually mean for workers in the long run? A lot of that depends on how executives and organizations implement this, whether they use it to cut costs or actually expand and grow into new opportunities, creating new jobs for people. Big question as well around the concentration of power. Will societies or economies that have access to these tools jump ahead and leave others behind? Will demand for these tools just make the Western tech companies that are producing them even more powerful? What will all this mean for the global world order? I also just want to mention a concern that you may have heard come up, it's being discussed, which is the threat of artificial general intelligence, which has a kind of squishy definition, but generally means AI that thinks like humans do and is potentially eventually smarter than us. The question some people have raised is what happens when computers become more intelligent than us? Will they simply take over, get out of our control, and how do we prevent that from happening? In fact, last year around this time, Geoffrey Hinton here, who invented backpropagation, was a pioneer of deep learning, said he was really worried about this, and he actually cited it as one of his reasons for leaving Google after many years. But other AI experts we've spoken with are not worried. So Jan LeCun, who is Meta's chief AI scientist, told one of our reporters he fully expects computers to be smarter than us one day, but he thinks that it will lead to a new renaissance for humanity, a new era of enlightenment, as he called it. So this concern is being discussed, but there's a lot of different views. And in our newsroom, we do think it's interesting, but probably not worth worrying too much about right now, because it's hard to know what'll happen. And there's a lot of more important short-term issues to focus on, like deep fakes and bias and some of those others that I mentioned. Now I want to give you a sense of where our team thinks this is all headed. So what's coming up next and what can we expect to see in the next year, couple years of AI. In terms of industry and research trends, we expect to see more multimodal models. So now you can prompt using not just text, but also audio, photos, videos, and you can produce outputs in all of those formats as well. Generative video is really the frontier right now. We're seeing a lot of action in systems that generate video. OpenAI is at the forefront of this, and they recently released that generative video model, Sora, in February. This is one of the short films that one of their creators produced using that model. You can search for it and watch it online. It's pretty funny. It's about a guy who has a balloon for a head and how difficult that makes his life. These systems have gotten a lot better. The first videos produced using these tools were really grainy, but they've come a long way and will only continue to improve. And there's another big research question is just how are we measuring these models? How are we measuring their performance? So you see a headline here that ChatGPT passed the bar exam. Well, what does it actually mean? Is that a meaningful way to evaluate these systems? They don't think like humans, so do we need better benchmarks to evaluate their performance? And there's a lot of research into that. Also the question of how these models really work. How do they do what they do? That seems like an obvious thing, but we actually don't really know. It's still a black box in many cases. And sometimes when you change the prompt a little bit, it can change the performance of the system quite a lot. And then there's also questions just about how do we train these models? Are there better ways to do that? The total number of connections in a large language model is still very tiny compared to what's in our brains, so these models can hold a lot more information, but they don't learn as efficiently. We require much less data and energy to learn something new. So can we get these models to learn more like a human child? We did a story recently about a research team's attempt to train an AI model by strapping a camera to this baby's head. The baby is named Sam. And so they strapped this camera to Sam and collected about 60 hours of video as Sam went about his day. And they used that data to train a model and found that it could learn from this footage to identify objects based on what people in Sam's life were saying as he was wearing the camera and looking at specific items. There's also quite a lot of interest right now in small language models. Big tech companies train these large, powerful models, but there's smaller ones that can be quite capable. The companies are training on their own data. Another frontier is math. So GPT and Gemini have been able to do basic math for quite some time. Claude 3 just got that ability last month, but none of them can really take on more advanced math like algebra and geometry, although a lot of companies are working on that. And there's growing interest in very specialized models that know a lot about one subject. I spoke with somebody last month at a different event who's building a model using genomic data to try and discover new drugs for rare genetic disorders. So thank you all for listening. I hope that was a helpful refresher. And we'll be talking more about all of these topics throughout the day. If you're interested in this kind of stuff and want to follow along with the conversation, I encourage you to subscribe to the Algorithm, our AI newsletter. It's free, it comes out every Monday, and you can scan this QR code to get all signed up. Now let's turn our attention to our next speaker. Michelle Dennedy is the co-author of the Privacy Engineers Manifesto and the CEO of Privacy Code. Her work focuses on new approaches for data security and privacy, and I know she's been thinking a lot about what all this means in this new era of generative AI. Welcome, Michelle.